So, hi everybody. Congratulations, you've all started your exams. Kai, do you have PE today?
Yes.
PE is not a real subject. Neither is English, which was on Monday. Get into the real subjects like maths and chemistry and biology and all those fun ones in the next couple of weeks. So we have this session this week. We will have next Tuesday's session. Then I might run one on the weekend as well, depending on how nice I feel. So we're going to practice acids and bases and some electrochemical cells. So as usual, guys, you've got 2 minutes. Have a think about this one. It's a pretty simple question. It just requires you not to overthink it. Yes, I know that sounds strange. So who's forgotten the molecular formula for acetic acid? Acetic acid is another name for methanoic acid. In case you're wondering. Oh, that's my favorite. All right, anyone have any ideas? So, what happens to any acid when we dissociate into water? What's the first part of the chemical equation going to be? Because guess what? It says to use an equation. So again, I'll stop sharing the question. So in beaker 1, we have, I'll clean myself so Washington can see. No, I don't like that one. So we got acetic acid, which is essentially just methanoic acid. So we add H2O, Kai. What does the methanoic acid produce? So we end up with CH3 and H3O+. So it's asking us to use a chemical equation to compare. So the other question is CH3 COOH, which is an acid, and add sodium hydroxide. Who remembers their grade 10 chemistry? We mix an acid and a base together. What do we get? Salt water. So we would have sodium acetate and water. The difference, key difference, is this is an equilibrium reaction. It can keep donating and receiving protons. Does that make sense? So when it says to use the chemical reaction, please use the chemical reaction. 3-mark question, 2 marks. Describe the difference. One makes salt and water, the other one ionizes water. There's your 3 marks. Don't think so hard. Oh, that's biology, that's not chemistry. Okay. All right, first. So again. So again, nice, easy 3 marks. We're starting chilled out, man. So 2 minutes is all it should take you. So remember the difference between galvanic and electrolytic. Remember, electrolytic cell requires a power source. All right, 30 seconds. So, Lucy, what are 3 components of our electrolytic cell? So there's a key difference here. Yes, we are using the same electrolyte solution. So what's the technical difference between galvanic Starts with S. Well, starts with S. It's a non-spontaneous reaction. So in an electrolytic cell car, we don't have a salt bridge. Because we're applying an electric current which moves the ions around. In a galvanic cell, we don't want the reaction to come to equilibrium, and the salt bridge allows for the ions to be passed back and forth. When the reaction in the battery reaches equilibrium, the battery is dead. This does not happen in an electrolytic cell. So we've got power supply. Because this is a non-spontaneous reaction, we need to supply an electric current to get the oxidation reduction reaction going. So over here we have the anode, where we have oxidation. Over here, we have the cathode, shock current reduction. In here we have an electrolyte. So electrolytic cell, we only use one beaker or one chamber. So electrons flow from the positive to the negative. Does that make sense? So these questions in this first part in your paper 2, never understand why they do it this way. These are not your complex, unfamiliar questions. These are all knowledge that you should have, that you have to apply to some pretty basic questions like draw an electrolytic cell. The other questions, you've got to think of it. So let's go down to question 1. And you'll see what I mean in the difference between the questions. What you'll notice here is that the galvanic cell is around the other one. So 2 minutes to have a think about the observation. So, the one pattern you should be noticing is that this is a chemistry exam. I know that may come as a shock. But in just about every question, you can sneak extra marks or marks that you might have lost by putting in a chemical equation. Any idea what chemical reactions we have in this instance? Yep, so what oxidation reaction is happening and what reduction reaction is happening. So we can write at the anode and reaction at the cathode. So what reaction is happening at the anode? So at the anode, we have zinc. We're taking away 2 electrons and producing Zn2+. At the cathode, we are what have we got here? We got oxidation or reduction. What have we got up here? So we've got oxidation. Reduction. So why do we have shiny anode? Because these guys oxidize, then fall into a solution. Unoxidized zinc is really shiny. Looks really nice, actually. On the cathode, we have iron atoms being reduced from iron 2+. So that's why it looks kind of gray and dull, because you've got iron being deposited. Now, the next part of the question asks us, what kind of voltage could we produce with this? So you need to go to your formula book, find out how many volts or the standard electrical potential of the oxidation of zinc, and then the reduction of iron. And you have 65 seconds here. So the oxidation of zinc, 0.76 volts. The reduction of iron gives us a negative. So we add those together, or another way, we just take them away from each other. So the electrical potential or the number of volts this could produce is 0.32 volts. The question stated that we produced 0.26 volts when we should have produced 0.32. Why might there be a difference between the observed actual value and the theoretical value in this instance? Yep, equipment could be one of them. And put 3 lines up here, 3 lines up here. Lucy's got it. Standard temperature and pressure. So if it wasn't 25 degrees, if it wasn't 1 atmosphere of pressure, and the electrolytes must have 1 mole per liter concentration. And if the electrolytes, if the cathode and the anode have impurities on them or they're not pure, all of this can reduce the voltage produced. Oh, what's this here? All right. Jen, another one of these pesky. Sorry. Everyone see question 7?
Yeah.
Perfect. So you've got 2 minutes. So if you think you've got them, put them in the chat. So again, if we go back to our basic knowledge of metals and non-metals, we will see that copper will always be oxidized. If you look at the reactivity scale in your formula books, we know that at the anode, we'll have the reaction so we'll have chlorine or 2Cl minus, sorry. Give us, because we know copper chloride, copper is Cu, chlorine is Cl. The formula would be CuCl2. So in this case, what we're actually seeing, 3 minus, is the negatively charged chlorine is being oxidized and the copper is being reduced. So let's go into the formula book. Electrical potential. If we go to our formula book and we go to page 11, you'll see this reaction produces positive 1.36 volts. The reduction of copper gives us .34. Now, when you're doing this, change the reduction into a negative. So that would give us 1.32 volts. That's the theoretical number of, or the amount of number of volts we could produce. Sorry. Oxidation number stays positive, flip the reduction number into a negative. So, sorry, Kai, you are correct, 1.02. My apologies. So, your formula book is there to help you. Please use it. All right. You have another question? All right, more pH, acids and bases. Everybody ready? Woo. So you've got 3 minutes. Calculate this. Any ideas how to do this one, guys? Okay. So how do we calculate the what do we need to calculate the pH? We need to know the hydroxide ion concentration. So the pH is the minus log of the H plus concentration. The H plus concentration for a pH of 9 is 1 times 10 to the power of minus 9 moles per liter. So pH is the minus log of H plus. We know that to be 9. We can convert that into the H plus concentration. So H plus concentration in this case who remembers the Kw of water or the ionic product of water? So 1 times 10 to the power of negative 14. So to calculate the pH, sorry, the ion concentration or the concentration of OH, we take our ionic constant of water or our Kw of water, and we divide that by this number. What does that give us? When we're doing about here, we were just 1 times 1 is 1. We know if you're doing methods, power of 14, negative 14, power of 9, we would have a to the power of negative 5. So that would be our hydroxide ion concentration. Pretty simple to break this down. Ionic constant of water divided by the concentration of H plus. That gives us the OH minus concentration. Where's the next acid base? All right, another galvanic cell question. So again, you guys, 2 minutes to have a think. Okay. About 2 minutes or so too quick. Sorry, still have 30 seconds. So the overall equation is not your oxidation and reduction. So on one side we have zinc, the other we have nickel. In this case, zinc will start off. And remember to remind me when I'm lazy, the states. Nickel will start off. Zinc will be oxidized to Zn2 plus and metallic nickel. That's the overall reaction. If you go to your formula book, you'll see that zinc has a higher propensity to be oxidized than nickel does. Okay, now that we've written our overall equation, we can determine the voltage that could be produced, the theoretical voltage, right? This doesn't change. And the reason I've gone over this like 3 times in these questions. So we have zinc becomes Zn2 plus 2E minus. So that's being oxidized. Again, we go back to our formula book. We can see that is 0.76 volts. We look at our reduction reaction, where we have Ni2 plus 2E minus, because we're balancing out the charge, gives us metallic nickel. Again, that's the formula book, page 11. We've got 0.24. Now, easy thing to remember, it's reduction. You make it a minus. So 0.76 minus 0.24 gives us 0.52 volts. Put your units in, you would lose a quarter of a mark. If I didn't even put volts there, you would lose a quarter of a mark. Okay. Yes. One more question, I think. All right. Again, very similar question to what we've been doing. So you guys got 2 minutes, have a read, have a think. All right. So we did this one at the beginning. We're talking about acetic acid, which is just ethanoic acid. So I'm not going to go through the answer to that one again because we've already done it. Actually, no, I will write it up because I think the sequencing is. So balanced chemical equation for dissociation of water. We take add H2O, conjugate acid, conjugate base. So we end up with CH3. Plus any acid where they're asking you for the dissociation of ethanoic acid or any kind of acid, it will look like that. Please don't overthink it. So it's asking us for the acid dissociation expression for the dissociation of ethanoic acid and water. If we remember to think about this like an equilibrium expression, we have our products over reactants. Now this is slightly different, and I'm going to show you the way that I do things. So normally you would write over CH3COOH. In an acid and base equilibrium question, because we are only concerned, sorry, that should just be C. So we do not write this. We get rid of the acid, or the conjugate base of the acid there. We just put H3O plus squared over the original acid. So the Ka, or the acid dissociation constant for this reaction, can be written like this. Now, remember that, write that down. Okay, so question C asks us to calculate the pKa value of ethanoic acid. This is in your formula book. So to calculate the pKa, we just take the minus log of the Ka value. The question told us that the Ka is 1.8 times 10 to the negative 5. Which in this case gives us the pKa for ethanoic acid is 4.7. And we'll finish this question next week, and we'll start with the end of this question when everyone is slightly less ingrained. So I think for the most part, everyone's struggling with the calculations, right? Not so much the concept of the topic.
Yeah.
Yeah. So next week, I'm just going to continue on this same track. Calculations, calculating theoretical yield, that kind of thing. And we'll finish this question, so we'll calculate the pH based on all these numbers, or the H3O plus concentration. I will see you guys next week. Is anything specific you want me to go through, please email me. It's getting really close now.
Thank you.
See you guys.